So now we've set up our email service to send generic emails, and we haven't actually tried sending real emails, and that's fine. We'll get to that in a little bit, but first let's talk about the strategy behind why we do this in the first place. We want to be able to allow users to reset their passwords, right? And the whole strategy behind password reset is actually completed in a couple stages. First, we need a way to allow users to make requests to recover their account. So when a user forgets their password, they'll send us the email associated with their account. We'll create a password reset token for them. We'll store that token along with an expiration date in the database. Then we'll send an email, and you know what? This actually might be good to write out a little bit. So let's just touch a password reset. Ooh, I like that. Password reset strategy.md. And let's write out a little bit what our password reset strategy, and let's write some details. So basically we want users to make requests to recover their accounts. Stages. 1. When a user forgets their password, can't type, otherwise this would be so much better, their password, they'll send us the email associated with their account. We will create a password reset token for the email associated with that account. I'm just going to do this, and I'm going to spell that correctly. Cool. Now, that token that we store for them, we're going to store in the database. So we store that token and an expiration date in the database. Then we send them an email with a unique link to a URL referencing our front end that includes their unique token. So it looks something like HTTP front end or rms.io/password reset token equals their secret token. Next, when the user opens the email, they'll click that link, go to our front end, and enter in a new password. Our front end will send that new password to our server with the token. We'll look up a user who has that token, and as long as the token is valid, we'll change their password. We'll also, we'll hash it first too. We'll hash their password and then change it. We'll also set the token and expiration date to null. Ta-da! Then finally, we'll send them a follow-up email saying your password was reset. And that's the whole thing. So this might not actually seem complicated, or maybe it does, but the steps associated with it take a little bit of forethought. And so we're going to go through them in pieces, starting first with changing the database to allow us to set a token in there for each user. So head into this ratemysetup.sql file and update it with the password reset token. So I'm just going to come here and say password reset token, and we're going to make that text, and password reset token exp, and we'll say that's a timestamp. Then just to make sure this all looks nice, I'm going to adjust these a little bit. Cool. Lovely. Ta-da! And after changing that, this table is like, again, this table's starting to grow a little bit in size, and we see here it's like, we got a lot of stuff going on here, and this is actually one of the reasons I tend to prefer splitting up user and user auth related info into two tables. So like one for auth and one for profiles, which can include things like their first name, last name, bios, stuff like that. And then to keep all the auth related things in another table. But for the time being, this works perfectly fine. We could even actually create an entirely separate table for tokens if we wanted, or just for all only serious auth related stuff. But again, this will do. And so to get this working, let's run the script to update the table. So we'll say psql-f rate my setup.sql. And boom, it worked. Boom, it worked. Looks like everything is set and ready to go. And so now we're able to store password reset tokens for users. As for tokens, we're going to be creating them slightly differently than we did with our JSON web tokens. So if you open up the utils file and go into the tokens.js here, you notice that we use the JWT file to create JSON web tokens. In this case, we're not actually encoding any information. We're not storing any information inside the tokens. We're just going to create a random series of bits encoded as hexadecimal. And to do that, we're going to import the crypto module. And the crypto module, you might be like, hey, you didn't install anything yet. How are you getting this crypto module? And you're right, I did not install anything. I didn't npm install anything. But the crypto module comes with Node. And if you actually look at the Node docs, you'll see that the crypto module is described as providing cryptographic functionality that includes wrappers for things like hashing, ciphers, signing, verifying functions, stuff like that. And so all of that is packaged within this crypto module, which is cool, which means we can do whatever we want with it. And you get it for free as long as you're using Node. And so let's actually create another function here. We'll say const generate crypto token. In this case, it's going to be a function that takes in a number of bytes that we want to use, and it's going to use crypto's random bytes. There you go. See, you got so many cool things here. We're going to use the random bytes method that takes in a number of bytes and creates a buffer array of pseudo-random bytes, and then we're going to convert it to a string. And that string is going to have an encoding of hexadecimal. And so that's all it's really going to do. Nothing super magical. We saw this pretty similarly when we were messing around with encoding in a previous video. But again, this is just another way to create a random series of bytes, pseudo-random, and then convert them, encode them as a hexadecimal string. So then let's go ahead and use that generate crypto token method to generate a password reset token. And this token will have a few things here. We're just going to simply return an object that has the results of generating a crypto token with 20 bytes, and also it expires at a new date that is date.now, so this exact moment, plus 60 times 60 times 1,000, and that's just an hour. Then we're going to convert it to an ISO string, so just format it as an ISO string, and that'll just means it gets easily stored as a timestamp in Postgres. And then let's go ahead and export that. So we'll say generate password reset token. Just like that. Cool. Nothing crazy. We'll save that. Make sure everything is still working as we expect it to. Oop. I have an error. Let's see. Oh, haha. I knew it didn't look right. There we go. Is that right? Nope, still have an error. Crypto.randombytes. Oh. JK. Let's try you one more time. Oh, I know what I did wrong here. It keeps auto-formatting. There we go. Beautiful. Cool. So all that's happening here is we have this generate crypto token method that takes a number of bytes and generates a random series, just a buffer array of random bytes, pseudo-random bytes, converts them to a hexadecimal string. We take 20 bytes, we create a token, a random hex token, and we tell it to expire in an hour. And so these two methods will allow us to then create password reset tokens and then store them for a user whenever they request it. And so to do that, we're going to head into our user model and update some methods to allow the user to store password reset token in the DB. But we'll do that in the next video. So stop here and handle all user-related stuff next.